Alright, hello guys. In today's video, we're going to be going over a problem like this, where we're given the equation in factored form, and we're asked use this equation to sketch a graph. So this graph isn't going to be perfect. I don't expect it to be perfect. I just kind of like a rough sketch, and there's a couple things that I want to see. I want to see that you can identify the x-intercepts from here, you can identify the y-intercept from here, and then you can identify where a graph is going to be positive and where it's going to be negative. And so those are the three things I expect. And how you're going to be doing that is using what are called test intervals. But before we get into the test intervals, we need to knock out the first two things on that list. So we need to figure out the x-intercepts and the y-intercept. So we're going to have multiple x-intercepts sometimes with these problems. Sometimes you might have one, sometimes you might have multiple. But you're only going to have one y-intercept. So let's start with the x-intercepts. To find these, you're just taking these three numbers right here. And if you remember what factored form does, so these three are in factored form, what it does is it takes the x-intercept and it flips their sign. So to take an equation, or to take a number that's in factored form and to convert it into your x-intercept, all you're going to do is take each of these numbers and flip their sign. So here we have a positive 5, so our first x-intercept is going to be at negative 5. Here we have a negative 2, so our next x-intercept is going to be a positive 2. And then lastly, we have positive 4, so our last x-intercept is going to be at negative 4. Let me make sure you guys can see that on the... Perfect. And then to find the y-intercept, all you're doing to find the y-intercept is you're replacing all the x's with zeros. So the y-intercept is just the value when x equals 0. So you could do this one of two ways. You could do the long process of going 0 plus 5 times 0 minus 2 times 0 plus 4. And you would ultimately get that this just equals 5 times negative 2 times positive 4. Which, if you look back up here, those are the three numbers I underlined: 5, negative 2, positive 4. So you could just do that every time for the y-intercept. This step right here of writing 0 plus this, 0 minus that, is unnecessary. You can just take those three numbers from where they are and then just multiply them. So if we multiply these, we get 5 times negative 2 is negative 10, and then negative 10 times positive 4 is negative 40. So our y-intercept is at negative 40. Okay, so now we can sketch a graph. I'll sketch a graph over to here. This is our rough sketch. We have x-intercepts, let's see, negative 1, negative 2, negative 3. So we have x-intercepts here at negative 5 and negative 4. And then we have an x-intercept over here at positive 2. And then our y-intercept is down at negative 40. So don't count all the way down to negative 40. Just put a point down here. Say it's negative 40. All right, so we got those three things labeled. Now, the last thing we need to figure out is the intervals. So this is where we use the test points that I was referring to. So we first make a number line, and we put these three numbers on our number line. So you go from lowest to highest. So we have negative 5, negative 4, positive 2. And you're going to be taking test intervals. So the rule you're using here is that we have 4 sections of this graph. We have everything before negative 5, everything between negative 5 and negative 4, everything between negative 4 and 2, and everything after 2. And the rule is that in each of these regions, our graph is either going to be entirely positive or entirely negative. So there could be a lot going on between negative 4 and positive 2. And rather than plugging in every single point into the equation to figure out exactly what that graph's going to look like, what we could do is we could just find one value between -4 and 2. And if that value, we plug it into the equation and we get it's a positive number, then we know this entire region is going to be positive. If we get it's a negative number, we know the entire region here is going to be negative. So that's all we're doing. We're just taking one point from these 4 regions and we're plugging that point into the equation and figuring out if it's positive or if it's negative. So this region right here, we could put, it's -5, so we put -6, -7, -8, -9, -100. I'll just put -6. This section between -5 and -4, we gotta be a little creative. So -4, -5 are consecutive numbers. There's no whole number between the two. So you gotta use a decimal. So I'll use -4.5. This one, if we can ever use 0, use 0, because we already found what 0 is over there. And then lastly over here, I'll use 3. And so now off to the side, I'm gonna make this section where I'm finding the values for my test points. So I have -6, x equals -4.5, x equals 0, and x equals 3. And I'm plugging those into the original equation. So first we have -6 plus 5 times -6 minus 2 times -6 plus 4. So this is -1, -8, -2. So this should equal -16. And so we don't care about, so this is a 16, excuse my horrible handwriting. We don't care about 16. We just care that we have a negative symbol in front of it. So that tells us this entire region is going to be negative. Since we plugged in -6, we got a negative number. Next, -4.5. We have -4.5 plus 5 times -4.5 minus 2 times -4.5 plus 4. And so this is 0.5. This is -6.5. And then this is -0.5. So we multiply those numbers together, it's gonna give us a decimal. I don't feel like doing the math. I just know we have a negative, and a positive, so that means we're gonna get a positive. So you multiply 2 negatives, you get a positive, multiply that with another positive, you're gonna get a positive number. Like I said, it doesn't matter what exact number we get here, it's just, we just care about if it's negative or positive. So we find out this region is positive, so we just put a plus. And then for x equals 0, we already found it over here. The y-intercept is just when x equals 0. And over there, we found that gave us a negative number. And so this one was -40. And then lastly, we'll plug in 3. So we have 3 plus 5 times 3 minus 2 times 3 plus 4. So 3 plus 5 is 8. 1, 7, so that equals positive 56. So this entire region we know is going to be positive. All right, so now we've got all our test points. We know our graph's going to go negative, that's going to hit -5. It's going to go positive after that between these two, negative between these two, and then positive to the off. So let me make some room on our graph. We can erase our test points. So now we're going to go to our graph. And this is just a rough sketch, like I said. Your minimums, your maximums aren't going to be perfect, that's fine. But we know our graph starts off negative until it hits the x-intercept at -5. So we're going to start off below the x-axis until we hit the point at -5. And then between -5 and -4, we're going to go positive. And then between -4 and +2, we're gonna be negative. And then we also know that we're gonna go through the y-intercept down here at -40. So we're gonna go down, 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 down. And then lastly, after we hit the x-intercept +2, we know we're gonna come back above and be positive. And so that's a rough sketch of what our graph would look like by using test.